Alright, exercise 4B, arithmetic sequences. Now, before we jump into arithmetic sequences, let's recap what we learnt last session. There are only two things you learnt last session that you need to understand. Name me one of them. Can I please have Summer? What did we learn? Good. Recurring sequences. Recurring sequences. What is a recurring sequence, Michael?
It's like defined by
Okay, good. So we have Tn, and he said Tn minus 1, and he had T1. What is this? Like the better definition of describing this. If you have Tn minus 1, what are you involving? What is it?
it's a sequence that requires a previous number to get that answer.
Fantastic. Recurring sequence is like a cycle. In order to move to the next answer, you need the previous, and that's the key word, needing the previous answer. So hence your equation normally will have something like this, something like that. Okay, so it means whatever the previous answer is, add 2. So that means if you want to find the next one after that, you still need a previous one. And that's a problem because if I asked you for the 100th term, that means you need the 99th term. But to get the 99th term, you need the 98, then 97, 96, 94, and then you go all the way back, and that's tedious. It takes too long to do. So that's recurring. Then you learn the second part, where you can change a recurring sequence to a, what do we call that, Daniel? Infinite. You have an infinite sequence. Difference between the two is an infinite sequence does not involve Tn minus 1, meaning it doesn't have the previous term. So you would have something like, if it's add 2 to every term, you can say Tn is equal to 2 times n. Okay, so it's adding 2 every time. It's like 2 to 4 to 6 to 8 to 10. You can say it's 2 times that nth number. Okay, and that now doesn't require the previous term. So if I want the 100th term, it'll be 2 times 100. Whereas this one, if I want the 100th term, I need 99. And that's a problem. Okay, so I need to go back to 98, 97, 96 until I get to the first one. Yeah? All right, so these are the two terms, and what I'm going to move on to now is arithmetic sequence, which is an example of a recurring sequence, and the formula they give you is based on an infinite sequence. Okay? But this in itself already is an arithmetic sequence. So, let's look at the definition. Arithmetic sequences is a type of recurring relation. It is specifically when you are adding a previous term to the next term. So it's adding. Any sequence that is a recurring sequence where you're adding. So you can add a -2. You can add a 3. You can add a 1. If you're adding it, it's arithmetic. Okay, adding negative makes it a minus really, but adding, anytime you're adding to the previous term, it is, whether it's a third or a fourth, doesn't matter. If you're adding something to the next, or to the previous term to get to the next, that is called an arithmetic sequence. For example, 1, 4, 7, 10, 13, 16. What pattern am I going with right now? Plussing what? Plus 3. So from 1 to 4, I add 3. From 4 to 7, I add 3. From 7 to 10, I add 3. From 10 to 13, I add 3, and so forth, right? Carries on. Now I want to write this as a recurring sequence. If I were to write this as a recurring sequence, starting T1, I start off with 1. Tn, I want to write a recurring sequence. How would you write this one? Yes? 1 plus 3. 1 plus 3 becomes a infinite sequence now. I want a recurring sequence. Tn minus 1. So this is now a previous term. What am I doing to the previous term? Adding 3. See, this is a recurring thing. Okay? So this is called the recurring term. What you just described before, which is what I want you to work to, is writing an infinite sequence. And you're right. It was Tn is equal to 1 plus 3 times n. See, this doesn't require the previous term. This one I can just say, find the 5th term, which is 1, 2, 3, 4, 5. The 5th term should be 13. So if I sub in 5, 4.
N minus
Sorry, n minus 1. It should be n minus 1. There we go. Because if this is the 5th term, we want the 4th term, n minus 1. And I'll show you how you can, that's what we were doing last session. We're trying to move from recurring to infinite. And I'll show you in this slide how we get to that n minus 1. It's 3 times n minus 1, 3 times 4, plus 1 gives you the 13, which fits what we're saying. But this allows you to find the 5th one without requiring the previous. So, how do we do this? What we did last session was we did t1 equals 1, and we were trying to find a pattern. That was our goal. We said, all right, well, t2 requires that you get whatever you had for t1 plus 3. So I'm color coding it so you can see how I'm going to change it to infinite sequence. t3, you need t2, add 3, and then you get t3. t4, you need t3 to add 3 to get t4, and so forth, right? Now let's try to change this to an infinite sequence now. To change it, you have to look for a pattern, which is what you were doing, Ben. So we said, all right, t1 plus 3. But t1, I can replace that t1 with the number 1, right? Which we'll do at the end. We'll do at the end. This is what t2 is. t3, so if I just write it all out, this is how you change from a recurring to an infinite. You write it out. t3 was t2 plus 3. But t2 is up here. See, t2 is equal to t1 plus 3, and that's what I've color-coded here. t1 plus 3, that's t2. That's my t2 there. Then t4, you said it's t3 plus 3, but I already know what t3 is. t3 is t1 plus 3 plus 3. So if I replace that over here, if I replace it, I get t1 plus 3 plus 3, which is what top line is. Now there's a pattern. So the pattern is what you can see here is when it's 2, you're adding on 1 3. When it's 3, you're adding on 2 3s. When it's 4, you're adding on 3 3s, or 3 groups of 3s. That's why you can say, oh, well, 3 groups of 3 is like saying 3 times 3. This is 2 groups of 3, so you can write that as 2 times 3. This is 1 group of 3, so you can say 1 times 3. So there's a pattern. T1 stays consistent, we know it's 1. So we write out the formula, which makes sense, where we say Tn is equal to 1, start off with 1, plus, now we notice when it's 3, you've got 2 groups. When it's 4, you've got 3 groups. So that's why it makes sense that you say n minus 1 is the number of groups that you will have. So if it's the 4th one, you'll have 3 times 3, which is what you were saying before. Yeah? Okay, so we just go through that. Now, this sequence that we just made up here, this is called an arithmetic sequence. Okay, this is the infinite sequence for it, but that's called an arithmetic sequence. And they're using different letters. If you're wondering like why it's like this, it's technically the same thing I wrote up here. They're just saying Tn equals to A. A represents the very first term. That's what it represents. If you look at it logically, A represents your first term. Plus n minus 1, well that makes sense, because you're always requiring the previous term. You're neglecting the first one, so of course it's n minus 1. And then D, what's D? D is 3. Where's 3 coming from? Add 3, add 3, add 3, add 3. So they call this letter D the difference. Well, the common difference is how they call it in the textbook. And that's just really the difference between 1 to 4, or 4 to 7, or 7 to 10. That difference is called D. Number of groups times that difference plus what you started off with will be the infinite sequence for that scenario. And this is called arithmetic sequence. How do we feel? Does that all make sense? Does it gel together? Okay, so if you think about 4a, this is 4a, recurring, infinite. That's where you were building, learning how to change it to infinite sequence. And now, this particular type of infinite sequence is called arithmetic sequence. In such the fact that you're just adding on 3 for every previous term. Easy? Yeah? All right. Let's do a couple of questions now. So just keep this in mind. A is the first term. First term. D is basically the difference between each terms. Okay? So let's answer the questions easily now. So they want you to find the 10th term of the arithmetic sequence. So we know it's an arithmetic sequence. That means it has to follow this pattern. Arithmetic meaning you're adding. Okay, so I know I'm adding, and I know this is like the formula that we've figured it out logically, that is the difference and whatever you're starting off with. Now A obviously has to be what? What's my A? -4. So I start off with -4, and then I'm adding because it's arithmetic sequence, so I know I'm adding. So from -4 to -1 I have to add 3. Okay, so in this case, it happens to be that A is -4, but D is 3. So my formula would be Tn is equal to -4 plus n minus 1 times 3. I haven't answered the question. The question says find the 10th term. So the nice thing is this is an infinite sequence, meaning you don't need the previous term. You can find the nth term by finding out t of 10. T of 10 should be -4 plus, when n is 10, minus 1, so you got your 9th term, times 3. So let's work this out. -4 plus 9 times 3, which is 27, and that gives me an answer of 23. Okay, and that's answering the question. How's that feel? Is that easy? Yeah? First term, last term, but I didn't want to just give you the formula. I wanted you to think how that came about. Okay, so it's starting from the very top theory, recurring theme to infinite sequence. This type of infinite sequence is called arithmetic. Easy? All right, let's do another one. You do this one now. If 41 is the nth term in the arithmetic sequence, so you know it's an arithmetic sequence, find the value of n. Again, that's the formula. I want you to work this one out, and then I'll do it too. I'm going to start writing the answers. We now know A is -4. D is the difference, still +3. Formula still Tn equals to -4 plus n minus 1 times 3. What we want to find out is n, the nth term.
Oh, yeah.
So, they already told us that final result is 41. So that nth term, the result is 41. You're just trying to find n. So that means it's 41 must equal to -4 plus n minus 1 times 3. We're trying to solve for n. So, basic sort of inverse operations, that's -4, add 4 on both sides. That gives me 45 is equal to n minus 1 times 3. Opposite of times 3 is divide 3, so divide 3 on both sides. And that gives me 15 is equal to n minus 1. Add 1 on both sides. And what does that mean? That just means my 16th term. So when t of 16, that should equal to 41. That's all they're telling me. So the 16th term. Hands up if you got this correct. Very good. Excellent. Try this one then. So each one comes back to like how well you understand theory. You understand theory, you can work this out. So same drill again. Whoops. There you go. Got your formula. You know that it's an arithmetic sequence. They tell you the 12th term, so T12 is 9, and T25 is 100. Just right. Find A and D. Once you find A and D, find the 8th term.
That was weird.
Yeah.
That's why you don't physics. What did you do? Just substitution.
It looks up. Oh my god.
You know what shit though? That's 9. 11. 43. Oh, isn't that? Oh, yeah, you didn't understand it properly. You could just do an easier live.
Whoops.
Isn't it the other way around?
Yeah.
Isn't
So 5 plus 1.
No,
Wait.
I was right.
Oh, I see.
Yeah.
What's that?
13.
A bit slow with my subtraction.
D said it's
Oh yeah?
oh. 7 plus what? What the? I did that differently. Oh, bad.
Wait, what did I do? I mixed it up.
That isn't. You should start the question. Talk about number. The last one.
Hands up, you got parts of the set of solution, or at least knew what you had to do, but you might have made an arithmetic error somewhere. All right, good, excellent. You just needed to understand when you say the 12th term, Tn, so n is 12, therefore you know that's n minus 1. That's 12 minus 1, 25th term, 25 minus 1. You've got two linear equations, two unknowns, simultaneous it, so you can either use elimination method or substitution. It's up to you. I use elimination, I just prefer that more, but both of them should still give you the answer. Now, last part of the today's session. So you've learnt what an arithmetic sequence is. You've learnt different ways to play around and solve either A, D, or N, or simultaneous them. And so the last one that you need to understand is called arithmetic mean. All right, so copy this one down. Arithmetic mean. What does it say? It says if the numbers A, C, B in that order are consecutive terms of an arithmetic sequence. So an arithmetic sequence, the one I gave you before was 1, 4, 7, right? Then A can be my 1, C can be my 4, and B is my 7. And in the sequence, C is called the arithmetic mean. It's the middle term in between those three terms from A to B, okay? And they're consecutive. That also means that because they're consecutive, and this is what they're saying, that means the difference between A and C, move from A to C, that is a constant, because it's an arithmetic sequence. So from A to C, you have to add something. You have to add, let's say, 3. A to C is 3, and then C to B is also 3. So it makes sense that if you found the difference between B and C, that constant is the same for the difference between C to A. So C minus A and B minus C has to be the same. Does that make sense? Yeah? So, by using that concept, we can simplify this problem down. We can say, well, let's add C's on both sides. So you get now 2C is equal to, add A on both sides, you get A plus B. And C, now you can write in terms of A and B. which C equals to A plus B divided by 2, which really just means find the average of A and B. So if you have 3 consecutive terms, you want to find that middle term, you just find the average of the first and the last. That will tell you the middle. That's what they're trying to tell you. So that middle number is called the average mean. Okay? That's all that is. And I'm going to give you a couple of questions. The last few questions of this exercise is interesting to use, and you need to understand this concept. It's easier to use this. If you understand it logically, doing the questions are easy for the last few. But if you don't understand what the arithmetic mean is saying, then you find it hard to solve, or you don't know what to do or where to start. Okay? So I'm going to give you an example. Just to start off, I'll do an easy one, and then I'll do one where you have to do a bit of thinking. Yeah? Here we go. Find the arithmetic mean of 8 and 15. Okay, so that means that there's a sequence. It goes for 8, there's number, gets to 15. We don't know what the sequence is. They haven't told us how many numbers you're adding. I guess you can figure it out yourself, but I'm just saying you don't know what A is, you don't know what D is, you don't know the nth term. They're just saying what's the arithmetic mean, finding C. So the arithmetic mean, this is your arithmetic mean, and C is equivalent to A plus B divided by 2, the average between them. Okay, in our case here, it would be 15 plus 8 divided by 2, and 15 plus 8 is 23 on 2, and that just tells me that's, yes, it's 11.5? Yes, it is. Okay, 11.5. So what does that tell me? It just means that I've now got 8, 11.5, 15. And I can work out the arithmetic sequence from here, because from 8 to 11.5, I know that that's adding on 3.5, so the arithmetic sequence must mean if I start at 8, I'm adding 3.5 each time. Okay, so that's what the theory is talking about. But they call that number 11.5 the arithmetic mean. Okay? Let's try, that's an easy one. Let's try this one now. Same concept. And I left the other questions, 18 and so forth, for you to think and play around with. But here we go. Find x if 3x minus 2 is the arithmetic mean of 5x plus 1 and 11. So if we try to understand what they're trying to say, well then 5x plus 1, then you got 3x minus 2 is the arithmetic mean. So that means that has to be the middle number, 3x minus 2. And that now gives me 11. What I don't know is whether 11's here and 5x minus, plus 1 is on that side. I don't actually know. I'm just putting it out there. This is the possible sequence. Okay? So I don't know if it's in that order, but what I do know is C is my 3x minus 2. Now they want you to find x. Okay, and so to find x, it's the same concept. We know the arithmetic mean is the average of the last two, or the first and the last term. So that means 5x plus 1 plus 11 divided by 2 has to equal to 3x minus 2. And all I'm using is C equals to A plus B divided by 2. Okay? C is my 3x minus 2, and A plus B is 5x plus 1 plus 11 divided by 2. Again, with fractions, if you don't like fractions, what do I always teach you? What do you do? Get rid of it. See, fraction is always divide 2. That's currently saying divide 2. Opposite of dividing 2, times 2 to both sides. So if I said left-hand side times 2, right-hand side times 2, that's fine. There's nothing wrong. Balancing the equation, two groups of these halves make 1. Or 2 times a half makes 1. So now I've got 5x plus 1 plus 11 is equal to double 2 groups of 3x is 6x, and 2 groups of negative 2 is negative 4. Now that's much easier to solve. Yeah? Minus 5x on both sides. That gives me x minus 4 is equal to 12. Therefore, x plus 4 on both sides. That gives me 16. So x equals 16. Is that mine? No? Okay. I have the same alarm. How do we feel with that? So today's lesson, the only thing I was teaching is what is an arithmetic sequence, recapped on recurrent sequences, and then also mentioned about infinite sequences that leads now to arithmetic mean. 4 things in total. Okay, 4 concepts, 4 things in total. So, Try these questions, especially the last few, 18, 19, 20. Especially 20. 20 is nice. And try to do these. So the first few.
I think we are.
There you go. I'll leave it there. Oh yeah. Hold on a second. I'm just going to stop the video.
Easy. No, hold on, it's because you just find the first value.